Hey guys, just wanted to give you a quick summary on mid-ocean ridges and deep-sea trenches and how they form. This whole thing forms a continuous cycle. We did some reading about mid-ocean ridges already, and we saw that in the mid-ocean ridge, the two parts of the oceanic crust, the plates there, they spread apart from each other, and when they do, they're able to get stuff squeezing up from beneath. Part of the mantle will turn to liquid and it'll come up from down below. And when it does, we get basically volcanoes, underwater volcanoes. It's wider than a volcano, though. It's lava coming out, but it's not just in one spot. It's all along this crack. And so when we have that, we end up with these big, tall mountain ranges forming as they stack up on top of each other. And then we also see that crack that's opened up is kind of filled in, but the two plates continue moving apart, so it just keeps getting wider and wider. More stuff gets released. The stuff that's near the crack is going to be the newest material, the stuff that hardened or cooled most recently. And as it gets pushed further away from the crack, and that takes time, so the stuff that's way out here is older material, and the stuff that's closer to that crack in the middle, to the mid-ocean ridge, that's the newer material. Now, if we stop right there, if we had a way for stuff to get from the inside of the Earth to the outside of the Earth, then we would expect over time the inside of the Earth should be emptying. And we've had a lot of time, we have 4.6 billion years. So it would make sense then there must be a way for the material on the surface to dive back down into the Earth. And that's where we start with deep sea trenches. So over here, we've got this represented. We have the hot mantle here, and when the hot oceanic plates, the warm ones that are close to the mid-ocean ridge, when they spread apart, we have more of that mantle liquefy and come out, and we get some bumpy structures as a result there. It's a little tough to see on the screen, but kind of some mountainous structures here. Here we still have the hot oceanic crust, but it's cooling as we get further and further away. And going back to what we talked about in the last unit with convection, when stuff cools, it gets more compact. When things warm up, they spread out, but when they cool, they get more compact. As a result, they get denser, and so dense things will tend to sink in less dense things. And so by the time we get all the way over here, where we have the well-cooled oceanic crust, that's about as dense as it's going to get. And when it encounters this chunk here, which is continental crust, and is moving this direction toward it, that continental crust, which is far less dense than the oceanic crust, especially the cold oceanic crust, the continental kind of stays up here at the surface. It's like it's floating on top, and the oceanic crust is sinking down beneath. And so it gets pushed down. Meanwhile, the continental crust, to have an arrow here, continental crust is getting pushed over to the right, and that's where we get our motion of the continents that Alfred Wegener described. It's a different mechanism than he envisioned, but we end up with a similar result here, that the continents do get moved as the oceanic crust moves. All right, now once that gets pushed down, it's no longer in the crust level, so we don't call it crust anymore. Now it's mantle, and the temperature is still cold. It's getting to warmer and warmer places, but it's like putting a frozen pizza in the oven. It takes a while for it to warm up. So we have this cold chunk of mantle, and because it's colder than the surrounding mantle, it's also denser than the surrounding mantle, which means it's going to sink. So it sinks down, 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 but as it gets down further and further, it also gets to warmer and warmer areas. And so it starts to warm up. So we go from cold mantle to just cool mantle. And now we have warm mantle, and it's going to get hot again. And when it gets hot, it's going to start to float back up. It's warmer than its surroundings here. And so it starts to float up above those surroundings. And so as it floats back up, we have it end up back at the same or maybe a different mid-ocean ridge. So we just have this continuing spiral or this circular path that we call convection, where the warm stuff rises up to the top, it hangs out at the top for a while, and as it gets colder, it's going to sink back down to the bottom, and as it sinks down to the bottom, it starts to warm up, and as it gets warmer, it's going to start rising back up to the top, and that cycle repeats. We have this recycling of crust material through this action. So we don't end up with the problem of having this be a one-way street. Over here, we were worried that the whole inside of the Earth was going to empty. Over here, we see, nope, that's not happening because here's a way for stuff to get back into the inside of the Earth. And then the last thing that I realized I forgot to point out here is that this feature right here, where the seafloor gets pushed down, the oceanic crust gets pushed down, produces this deep area in the ocean. And I'm just going to give the full name here. That is not a mid-ocean, a deep sea trench. Deep sea trench, when a continental and an oceanic crust plate meet, and the oceanic crust plate gets pushed down, it also kind of dragged the continental crust down a little bit. The edge will get dragged down a little bit. So we end up with this kind of V shape, this deep valley in the seafloor. And those are our deep sea trenches. Those are the deepest parts of the ocean. So the next step then is mapping out where do we see these, the mid-ocean ridges, since that's a gap between two oceanic plates. And where do we see these deep sea trenches, because that's the boundary between a continental and an oceanic plate. And we get to start mapping out where the edges of our plates are. Thanks very much for watching. Hopefully this helped fill in any gaps from stuff that you missed. And let me know if you have further questions.